So I'm going to kind of skip why it works, but if we have any triangle, what is the formula for the area of a triangle? Right, base times height divided by 2. Or the way the book wrote it is usually 1/2. Whatever. 1/2 base times height. So if we use this as the base, the height would look like this. It's got to be a vertical line that's perpendicular. And so what's new with trigonometry is if we know an angle over here, then that's enough information to figure out what the height is using the sine function. Sine gives us opposite over hypotenuse. So what information you'd need would be this side and this side to find the area. So if you don't know the height of the triangle, you can use this formula. Instead of 1/2 base times height, it's 1/2 these two are kind of that's the formula. So what do I mean by A and B? A and B are the two sides of the triangle that are around the angle, and the angle is always what goes into the trigonometric function. So it's sine of the angle. 1/2 times side times sine of the included angle. So it's always got to be side angle side for this to work. If you have a side angle side, you can use this formula. So this is side angle. Doesn't really matter which side you put in first. Order of multiplication doesn't matter. But that would give you the area. So on number 1, the sides are 8 and 6, and the angle is 87. So we're going to do 1/2 times 8 times 6 times sine of 87 degrees. And that will be the area. And it says round your answer to the 10th place. Let's plug that in and see what we get.
So what's the C at the end of those?
C is the angle. That's in between.
Oh, okay. I thought that was the other side.
23.9671088.
What?
23.967.
Okay, if
Oh, you
we're
said
at,
10. Okay, so 24.
okay, how did we label areas? Centimeters squared. Okay, number 3. So 8, 3, and 98. So 1/2 times side times sine of 98. Okay, let's go ahead and jump to the back. The back is quite a bit harder, but there's not many questions though. Okay, so we're supposed to find the area of each regular polygon, still rounding to the 10th place, so that's number 9. Can you guys tell what shape number 9 is?
Octagon?
I don't think I got enough sides.
No, there's an she said.
Yeah, Yeah, it's a nonagon. Okay, if I were to draw in the center and draw in the radii, which is like, we kind of did areas of regular polygons once upon a time. You guys remember the formula for a regular polygon? Yeah, that's right. Good job. 1/2 apothem perimeter. We're not going to be using that for this. We're going to be using the new little trick. So if I draw in the radii on a nonagon, nonagon means 9 sides. How many triangles would be created if I drew them in here? 9. Okay, it's an ugly nonagon, but just pretend it looks. If it was a perfect regular nonagon, all the triangles would be the same. Says the perimeter is 108 miles, I guess. How would I figure out what this angle right here is? Any ideas? Huh? 360 divided by 9, because there's 9 triangles, so there's a full circle right here, split into 9 triangles. So 360 divided by 9 is 40. Okay, the perimeter is 108. So how long must each side be? Or how would I find the length of one side? Right, 108 divided by 9, in this case would be 12. So this is 12 miles right there. Okay, if I draw in the apothem, it's going to create right triangles. What would this little angle right here be? 20. It's going to be half. What would this leg of the right triangle right here be, just from there to there? 6. Okay. Because I have an angle, if I can just find these two sides, which by the way they're going to be the same, right? If I can find one of these sides, then I'll have side angle side, and I can find the area of this triangle. Once I get the area of this triangle, I do it times 9 to get the area of the whole thing. Okay, how can I find the length of this side? It's like the radius, it's like the hypotenuse of this. Okay, relative to this angle right here, what side am I looking at there? And which trig function does opposite and hypotenuse? Sine. Sine of the angle equals opposite over hypotenuse. What do we do when the r is on the bottom? Okay, multiply by r divided by sine of 20. These two switch places. So r equals 6 divided by sine of 20. Let's round that to like 4 decimal places or something. Gotta go kind of far. Anybody plug it in?
7.5428.
Okay. When I did this with the other class, even this wasn't accurate enough to get a perfect answer, but we're gonna settle for this. So this is this thing, the radius, 17.5428. So we have a triangle right here that has a 40-degree angle and then a 17.5428. 17.5428. Okay, so that's enough information. We have side angle side. That's enough information to use our little formula from the front page. So it's 1/2 times side times sine of the angle. Now, what did we just find? We found the area of this triangle.
So you do that times 9.
Yeah, so all that answer you just got, since there's 9 triangles in a nonagon, you have to do times 9 for the final answer. Alright, what did we get?
890.2.
890.2. Everybody concur, let's see what they put. I do that. For some reason the other class got like 890.3. Did you get 0.3? You got 0.1? It is 890.2 though. So how... Xander's was right, yours was 0.1, we were 0.1 off the other day too. Anyway, wait, was it 0.2? I forgot now.
Yeah.
I don't know, it's a mystery. We'll just keep moving though. Okay, number 10 is kind of good news on that one. If 10 is a regular triangle, what kind of triangle must it be? Equilateral, right?
Yeah.
What must each angle of an equilateral triangle be? Same 60. 180 divided by 3. So you have the side on the bottom is 10, so that means all sides are 10, and each angle is 60. So you already have a side angle side. You don't need to do, you can just do that. There's just one triangle there, so you can just use the formula from the front page. Okay, but on number 11, it's going to look like number 10. How many sides do you guys think number 11 has? I'm not going to even try to draw that one. Yeah, I think she's right. I don't suppose anybody remembers what a 12-sided is called, do you? Dodecagon. 10 sides is decagon. 12 is dodecagon. I don't know what 11 is. You know what uses it, I guess. Yeah, so it says on this one, perimeter is 144. So that means all 12 sides add up to 144. So each side is 144 divided by 12. So we got another 12 down here. Okay, how would I find the central angle right here?
Uh,
360 divided by, in this case, 12. 30 degrees. And if you split it in half to get a right angle there, you get a 15-degree angle. And again, if we split the 12 in half down here, this would be a 6 on this leg. So we're going to use the exact same trick we used last time to find the radius, the hypotenuse. Relative to this angle, we have the opposite and we're looking for the hypotenuse. So we need to use sine equals opposite over hypotenuse. We could use the 1/2 apothem perimeter thing. It would still require trigonometry either way, but anyway, so when the r is on the bottom, these two things switch places when the variable's in the bottom. So it's r equals 6 divided by sine of 15. Four decimal places.
23.1822.
0.1822.
Yeah.
Okay, so that's our radius, and it's on both sides. 1822. So we got side, angle, side. So it's 1/2 times side times side times sine of that central angle 30. That would get us one triangle. How many triangles does a dodecagon have? So we need to times 12 on the end of that.
I got the answer.
Alright. What did you get?
1612.2.
You got what?
1612.2.
1620.2. Point, what? 612?
Yeah, my bad.
I'm a little bit deaf. Okay, 13 is a regular hexagon, and if you look at number 12, what's number 12? You know, it's a hexagon also.
I didn't know.
So 6 sides is hexagon. So what I'm doing on 13, you can kind of reproduce it pretty closely on hexagons. There's something kind of special about hexagons. You don't really have to do anything different, but there's kind of a quick trick. Because when I draw in that central angle, what is the central angle going to be? 60 degrees. And when I split it with the apothem, it's going to be 30 degrees. And that's 90, so it's a 60, 30, 90. It's a special right triangle. So we could use trig, but if you remember the special right triangle ratios, we could use that too. It says the perimeter is 48 yards, so what must each side length be? 48 divided by 6 is 8 yards. If the whole side is 8 yards, how long is this little leg right here? 4 yards. Okay, here comes the trick. You guys ready? If the short leg on a 60, 30, 90 is 4, what's the hypotenuse? 8. The short leg to the hypotenuse is just double. You could use trigonometry to figure it out if you didn't know. Just like we did on the other two, but it's a little bit faster if you use 8. So the central angle was 60, and we have 8 and 8. You guys want some AC? I feel like it's slightly warm. What about this side? Are you guys warm enough for a little bit? Or no, but the vents are closed.
Huh? Oh. Mr. Jordan, what did you put?
You got that. You get glasses. What do you got?
Yeah.
We'll pass around the hairball later. Okay.
Squishy.
It's literally a hairball.
It's squishy. Yeah. It's squishy.
So 1/2 times side times side times sine of 60. How many triangles will a hexagon have in it? 6. So that will do it.